To summarize the DDD trilemma, this is the solution I recommend for validating email uniqueness. Do that in the controller. We violate the always valid domain model guideline with this particular check, but preserve domain model purity, which is more important. Let's now take a look at the rest of validations in our controller. In the edit personal info method, we need to check that the student exists. We are doing it the same way we checked for email uniqueness. Notice that I am passing the name of the ID argument as the field with error. It's generally a good practice to indicate the field to which the error relates the closest. We don't need this code anymore, and I can copy code that creates the list of addresses. And I can also copy the transformation code for the student name. Again, we haven't introduced a value object for this field due to the rule of thumb we discussed earlier in this course. We are only creating value objects if the field has more than one invariant. Now we can pass this name into the edit personal info method in the student instance. And if we look at our validators, we should already have the validator for this controller method. Here it is. Alright, the last method here is enroll. In this method, we also need to check that the student exists. In addition to that, we need to perform validations of the course enrollments. We need to check that the course with a given name exists in the database, and if it doesn't, we need to return an error saying that the value is invalid. Note that we also need to specify the field name. That field name will consist of the enrollment collection field, the index of the specific enrollment in that collection, and the name of the course field. To get the index, we need to transform the for each loop into a for loop. Let me rename the DDO. And now we can use the index like this. Very good. We also need to validate the grade. This grade is currently an enum, and it's a good idea to convert it into a value object, because this domain concept is more complex than just a string. Like in the example with the states, here we too will need to check the input string against the predefined list of values. Let me comment the enum. The value object is going to consist of just one field, and we can explicitly specify all the possible values this value object may have. This pattern is called the enumeration pattern, a property that lists all of the grades, and the create method. In that method, we will check for the string non-emptiness, transform the string by trimming and converting it into the uppercase, check the length, and finally check that the grade is among valid grades listed above. Now we can use this value object in the controller. Here we once again instantiate the value object without checking the result of the factory method. That job is for the Fluent validator. I'm creating it now. A rule for enrollments. It should not be empty. It should contain at least one enrollment. And we can also specify rules for each enrollment in the collection, without introducing a separate validator. Each enrollment should have a course name that is not too long, and a grade whose validity we check using our value object. Let's run the application and test these validations. Let's register Carl first. And now let's try to enroll him into a course without a name. And you can see that the API returns a proper error and that it also specifies the correct field name, which includes the full path to the course name. And if I change the grade to some invalid string, the API handles that too. Let's actually enroll Carl into these two courses. The enrollment is successful, very good. But we still have a couple of edge cases that we don't handle properly. If we try to enroll Carl again, you can see that the application throws an exception. As we discussed previously in the course, exceptions should only be used as a save fail mechanism to signalize a bug in the application. We shouldn't build our validation process using exceptions. Before we refactor the student class away from exceptions, let's fix something. We need to do the transformation for the course name. similarly to how we did it for the student name. Good. So how can we change this method so that it doesn't rely on exceptions? The first option is to make it return a result instead of throwing an exception. This is a perfectly valid option and we will go with it, but let's also discuss another perfectly valid alternative. Instead of doing everything in the enroll method, we can introduce another method called canEnroll, where we can put all the validations related to the student enrollment, like this. Then we can make the enroll method use the canEnroll as a precondition. This is another sanity check to make sure that the controller has called the canEnroll method before invoking enroll. In the controller, we can use canEnroll like this. Get the result out of it, check if it's a failure, and return an error if it is. Note once again that this approach with two methods, one for action and the other one for validation, violates the third guideline of validation, called validation is parsing. This guideline tells us that we should combine the operation itself with the process of its validation. This use case falls into the exception to that guideline though. Here we don't need to do any transformations, only the validation, and thus we can separate the two methods. Should we have any transformations, let's say for example merging duplicated enrollments into one before validating them, then we would not be able to keep the two methods, because that would lead to duplicating that merging logic. We only need to keep validation and operation itself together if that operation involves transformation. Alright, we will keep the enroll method as one though. Unlike the create method, this method doesn't return anything other than the result of the operation. Right now, this library doesn't have a variation of the result class with only the error type argument. By the time you watch this course, I will most likely add it there. It will be called unit result. For now, we can use a stub for the return type, something like an object. Or you can also introduce a handwritten class called unit that would emulate a void result. Let's add these two errors to our list of errors. The first one is going to be too many enrollments, and the second one student already enrolled. Now we can use them here instead of our strings. And return the object stub if everything is fine. Again, you can achieve the same result with the custom unit class. Now in the controller we can get the result of the operation and return an error if it's a failure. Very good. We can delete this and run the application. Let's register Carl again, enroll him, and enroll again. The second enrollment request shows the error we just introduced, that the student has too many enrollments. In the previous demo, we've completed the rest of the validations in the controller. Let's take a closer look at the enroll method. This method contains more domain logic fragmentation than the other controller methods. For example, this loop adds quite a bit of cyclomatic complexity. Here's our diagram showing the DDD trilemma again. Can you say which option we chose with this approach? Feel free to pause the video, I'll wait a couple seconds. Ready? This is the same trade-off as we did with the email uniqueness check. We've delegated some of the invariants to the controller in order to preserve domain model purity and application performance. If we were to choose encapsulation over purity, how would we proceed? I don't recommend that you make this choice, by the way, but it's still a nice exercise to go through. To preserve encapsulation over purity, we could move this for loop into a factory method in the domain layer and inject the course repository as an argument to that method. Finally, how could we implement the third option that preserves both encapsulation and purity at the expense of performance? We would need to push all these getByName method calls to the edges of the controller method. That would be an even better option that we have now. Here's how this version would look like. We would need to request all existing courses from the database so that we could pass them to the factory. But it's unlikely that we will have too many of those courses in the database. Also, we could probably cache them, and so the performance impact wouldn't be that drastic. At the same time, better encapsulation would help us adhere to the good validation techniques and would allow us to unit test this logic without resorting to mocks or setting up the test database. The only downside to this refactoring is that we will lose the information about which field contains an error. This is a good exercise, so try to implement this option yourself. The very last commit in this course's source code repository will contain this refactoring, so that you can compare the notes. I've received a lot of great questions for this course. Unfortunately, I couldn't fit them all into this course. I'll try to answer all, or at least most of them, on my blog at enterprisecraftsmanship.com. If you want to receive announcements about new courses or participate in choosing the topic for my future courses, subscribe to my email list using this link. I send out polls that help me decide which course to work on next. This course consists of two parts. In the first part, we discussed the features of the Fluent Validation Library. In the second, the topic of validation in general and how to combine it with Fluent Validation and domain-driven design patterns. You learned the three building blocks of the good validation technique. First, your domain model should always be valid. Second, all validation rules should belong to the domain layer. And third, the validation of an operation cannot be separated from the operation itself. These are general guidelines, and it's best to adhere them as much as possible. Sometimes, though, you will have to violate them. For example, the most simple validation rules, such as checks for maximum string length, are best kept outside of the domain layer, just because otherwise you would have to write a lot of repeating and low-value code in your domain model. Second, there is also the DDD trilemma that tells us that we cannot have both domain model encapsulation, which helps us keep the domain model always valid, and domain model purity. You will have to make a trade-off between them. Sometimes you can give up performance to have both encapsulation and purity, but most of the time you cannot do that. In this case, choose purity over encapsulation. Again, you can subscribe to my email list using this short link. Also, here are my Twitter handler and blog. This is Vladimir Horikov. Thank you for listening.